This is our last video in simplifying complex fractions. So in the last video we talked about how we need one fraction in the numerator and one in the denominator, and then we can change it to change division into multiplication. So in this example you notice that the numerator has two fractions and so does the denominator. So we need to find an LCD, and the LCD of our numerator is just going to be w plus 2, w minus 3. So in our first term we're missing the w minus 3, which of course I didn't write correctly, so let's write that correctly. W minus 3 over w minus 3, and we're going to multiply that by 1 over w plus 2. In our second term we're missing the w plus 2, so I'm going to multiply, whoops, that's a 2. I'm going to multiply that by w plus 2 times 4 w minus 3. And I'm just going to continue with the numerator, and I'm going to distribute this 1, and I have a w minus 3 over the LCD, plus I'm going to distribute this 4w plus 8 over the LCD. Okay. So now let's take a look at our denominator here. We have the same LCD in our denominator. So the factor that's missing in the first one is w plus 2. So we're going to multiply the first one by, oops, again, that's a w plus 2. And in the second one, we are missing w minus 3. So we're going to multiply the numerator and the denominator of our second fraction by w minus 3. And let's go ahead and distribute. We have 2w plus 4 over the LCD, which is the same as the numerator, but it's a subtraction here, 7w minus 21 over that LCD. Okay, so like I warned you before, we need to put parentheses around any of our binomials so that when we combine into one fraction, we don't forget to distribute anything. So we have a w minus 3 plus 4w plus 8 over w minus 3, w plus 2. All over, in our denominator we have a 2w plus 4 minus a 7w minus 21 over w minus 3, w plus 2. Okay, so in the numerator, the first, we have a positive 1 in front of both of those, so we don't really need parentheses, so we're just going to add like terms. We have 5w plus 5 over w minus 3, w plus 2. And now remember, we have to distribute this negative. So we have a negative 7w plus a 21. So when we combine like terms, we're going to have a 2w minus 7w, which is a minus 5w. Here we have a 4 plus 21, which is a positive 25. And that's why we need parentheses, or we forget to distribute. Okay, so now let's put our parentheses in the numerators. And we have one fraction in our numerator and one fraction in our denominator. So now we can change division into multiplication. So we have 5w plus 5 over w minus 3, w plus 2, and we're going to multiply by the reciprocal of our denominator. So we have w minus 3, w plus 2 times, oops, I forgot those parentheses, negative 5w plus 25. And what's going to reduce? Well, both of them have a w minus 3, a w plus 2. So we end up with 5w plus 5 over negative 5w plus 25. So we need to simplify this fraction, and I notice we can factor out a 5 in the numerator, w plus 1, and we can factor out a negative 5 in the denominator, w minus 5. And 5 over negative 5 is negative 1 times w plus 1 over w minus 5. Okay, so the 5 and the 5. Okay, so I move that negative that was in the denominator up to the numerator because that's where I like it. Some teachers will require you to distribute this. Doesn't really matter to me. I would accept that answer or negative w minus 1 over w minus 5. I don't like that negative to remain in the denominator. Okay, so that was a really long problem. So now let's take a look at the next one. If you need to write this down, go ahead and pause the video before I erase everything. Okay. Alright, so now let's work on the next one. Okay, in this example, I want you to notice that we have negative exponents, so we have to deal with our negative exponents first. And we know that anything raised to the negative 1 really just means take the reciprocal. So this negative exponent right here, this is the most common mistake. It is only being applied to our x, not the 2. So we take the reciprocal of x, not the 2. The 2 remains in the numerator. The x moves into the denominator of the 2. Okay, so this negative 1 here says take the reciprocal of n. So we're going to add to it 1 over n. Now what do we do in our denominator? And this negative exponent means take the reciprocal of m and change our exponent to a positive 2. Okay, and this negative 1 is only applied to the n, not the 4. That's the most common mistake. So don't forget that the exponent is applied to what it is right next to, not the thing that's 2 away from it. Okay, so here we have, clearly we have 2 fractions in our numerator, and the LCD in our numerator, we have a unique factor of x and a unique factor of n. Alright, so we are going to multiply our first fraction. We're missing the n, multiply it by n over n. And then we're going to multiply our second fraction. It's missing the x, so we're going to multiply it by x over x. I want that in red. Okay, x over x. Okay, in our denominator, what's the LCD of our denominator? Well, we have a unique factor of m, and its exponent is 2, and then we have a unique factor of n. Okay. So in our denominator, this first fraction is missing the n. So we're going to multiply the first fraction by n over n. And the second fraction is missing an m squared. So we're going to multiply the second fraction by m squared over m squared. Oops. Okay, so let's go ahead and multiply out. So in the numerator we get 2n over xn plus x over xn. And in the denominator we are going to multiply out and we get n over m squared n. And then we get minus 4 m squared over m squared n. Okay, so now we have common denominators, so we can combine terms in our numerator, combine terms in the numerator of our denominator. Okay, so now we have one fraction in our numerator and one in our denominator. So we can change multiplication or division into multiplication by flipping, multiplying by the reciprocal of our denominator. So we have 2n plus x over xn times m squared n over n minus 4m squared. And let's go ahead and apply our parentheses. And if we notice, what reduces is the n. And that looks like it's the only thing that reduces, because this binomial does not factor and this binomial does not factor. There's no GCF. They're both not perfect squares or perfect cubes. So we are left with m squared times 2n plus x all over x times n minus 4m squared. And that completes our lesson on simplifying complex fractions.